All right, welcome. Today, we are going to pull back the curtain on something that is honestly a core part of what makes Java so powerful. We're talking about dynamic method dispatch. It sounds kind of technical, I know, but it's the secret sauce that lets you write incredibly flexible code. Code where one single command can do a bunch of different things. So, let's dive in and see how it all works. So, let's start with a puzzle. How is it even possible that you can write one line of code like the exact same method call, and have it do completely different things depending on the situation? That's really the big question we're going to unpack today. Okay, so one interface, many behaviors. This really gets at the heart of the challenge, right? The goal here is to write code that's flexible and scalable. We want to build this one stable way of interacting with our code, an interface that can handle all sorts of different objects, even objects we haven't even thought of yet. And the key is doing it without having to go back and tear apart our existing code. So why do we even care about this? Well, it's a huge deal. First, extensibility. You can add new features without worrying about breaking everything you've already built. It also helps you create really clean, simple APIs that are easy for other people or your future self to use. And this is a big one. You get to avoid those massive, messy if-else or switch statements that are just a nightmare to maintain. It's all about writing smarter, not harder, and reusing the solid code you've already got. All right, so how does Java actually make this happen? Well, it's this really elegant two-part solution. The first part is something you do as the programmer. It's called method overriding. And the second part is what Java does for you behind the scenes when your program is actually running. That's dynamic method dispatch. So let's talk about method overriding first. Think of it like this. A parent class gives its child class a set of abilities, or methods. But the child class might say, you know what, I'm going to do that one thing a little differently. So it provides its own version of that method. The most important rule here is that the method's signature, that's the name, the return type, and the parameters, has to be exactly the same. You're just swapping out the implementation.
And method overriding works because of this other piece of the puzzle, dynamic method dispatch. Now, this is the magic Java does. It basically means Java doesn't decide which version of the method to call when you compile your code. No, it waits. It waits until the program is actually running. And then it looks at the actual object in memory and says, aha, this is the version I need to call. It's not about the variable type, it's about the object's type. Let's make this crystal clear. Look at this little snippet. We have a variable r, and we've told the compiler, hey, r is going to hold things of type A. That's its reference type. But then at runtime, we actually create a new object of type B and have r point to it. So when we make the call r.callMe, Java ignores the fact that r was declared as type A. It follows the pointer, sees the object is actually a B, and runs B's version of the callMe method. The object decides, not the reference. That's the whole game.
Okay, enough theory, right? Let's see this thing in action. I've got a couple of code examples that are really going to show you the power of this.
So for our first demo, check this out. We've got one variable, r, that we've declared as type A. But then we're going to play a little game with it. First, we point it to an A object and call the method. Then we take that exact same variable, r, and we point it to a B object, call the method again. And then one more time, we point it to a C object. Notice, the line r.callMe is identical every single time. The only thing changing is what r is actually pointing to. And boom, look at the output. A, then B, then C. 3 identical calls, 3 totally different results. That's not magic, that's dynamic dispatch. You can almost imagine the JVM at each step looking at R and going, okay, what are you really? Oh, you're an A? Let's run A's method. Then, okay, now what are you? At B? Cool, B's method it is. It's making that choice on the fly, every single time. Okay, let's look at something a bit more practical, something you'd actually build. Imagine we have a bunch of different shapes. Here we've got an array of figures, but inside this one array, we're mixing and matching. We've got a rectangle, a triangle, even just a generic figure. Now, look at the loop. It is beautifully simple. It just says, for every figure f in my list, just call f.area. The loop has no idea what specific shape it's dealing with, and it doesn't need to. And just look at the output. It works perfectly. When the loop hits the rectangle object, it calls the rectangle's area formula. When it gets to the triangle, it calls the triangle's area formula. The loop code itself is totally generic, totally clean. Java is doing all the heavy lifting, picking the right method for the right shape every single time. This is what makes your code so much cleaner and easier to scale. Okay, so to really get this down, there are a few rules of the road you've got to know. We'll cover some pro tips and also clear up one of the most common mix-ups people have. All right, pay close attention here because this is a big one. Do not get overriding and overloading confused. They sound similar, but they're totally different things. Overriding is a runtime thing. It's about two different classes and the same method signature. Overloading happens at compile time. It's about having multiple methods with the same name but different parameters, all inside the same class. One is about specializing behavior, the other is just for convenience. They are not the same. Now, here's a pro tip that will absolutely save your skin one day. Please, please, please use the @override annotation. Think of it as a little message to the compiler saying, hey, my intention here is to override a method from my parent class. If you accidentally make a typo in the method name or mess up the parameters, the compiler will instantly give you an error. Without it, you might just be creating a brand new method by mistake, leading to some really nasty, hard-to-find bugs. It's also super important to know what doesn't get overridden. You can't override static methods. They belong to the class, not the object, so they don't play this game. You can't override private methods because a subclass can't even see them. And of course, constructors and regular old variables or fields aren't part of this either.
Okay, you ready for a quick pop quiz? Let's see if this is all sinking in. We've got an animal class with dog and cat as subclasses. Now look at the code. We create 3 animal variables. A1 points to a dog, A2 points to a cat, and A3 points to a plain old animal. So, what happens when we call speak on each one? What's the output going to be? Take a second, pause if you need to, and think it through. And the answer is dog, cat, and animal. If you got that, awesome, you've totally got it. For each call, the JVM did its thing. It looked past the animal reference type and checked the real object. For A1, it saw a dog. For A2, a cat. And for A3, just a regular animal. Perfect example of dynamic dispatch. Okay, let's wrap this up with the key takeaways. First, overriding is what you do. A subclass provides its own version of a method. Second, dynamic dispatch is what the JVM does. It picks the right method at runtime based on the actual object. The big benefit? You get super flexible, extensible code. One interface, many behaviors. And please, remember, use @override and know that things like static and private methods don't get overwritten.
And now it's your turn to really feel the power of this. Here's a little challenge. Go back to that figure and shapes example. I want you to create a new class called circle. Have it extend figure and give it its own area method. Then just drop a new circle object into that array and run the program again. What happens? You'll see that you don't have to change that main loop at all. And that, right there, that is the whole point. That's the magic of dynamic method dispatch in action.